Hello everyone, my name is Palki Jain from vidyanandonline, and if you are new to our channel then consider subscribing right away. Now I am going to share that we have completed the entire range of chemistry class 10th. So here if you can see, we have all the chapters uploaded, be it periodic classification of elements, carbon and its compound, metals and non-metals, or acid, bases and salts, or chemical equations and reactions. I have also ensured that in order to ease your learning, I make a separate playlist. So if you see here, we have separate playlist for every chapter. So if you like our videos, then do like them and also share with your friends. Now let's start with our session. So the physical and chemical properties of elements shows regular variation if you move in left to right in a period or if you move up and down in a group. Now these variations are actually called as trends in modern periodic table, or you can also say it as characteristics of periods and characteristics of groups. So let's start with characteristics of periods in modern periodic table. So let us understand the variation of some of the important properties of elements on moving from left to right in a horizontal row of the periodic table. So these are the properties about which we are going to talk in this session. So we are going to see what will happen to the valence electron if you are moving from left to right, what will happen to the valency of elements, what will happen to atomic size, what will happen to metallic character, what will happen to chemical reactivity and nature of oxides of elements. So first of all, let us talk about valence electrons. So what are valence electrons? Valence electrons are the number of electrons in the outermost shell. Okay, so if I talk about this period, so this period is period number 3. It is a short period consisting of only 8 elements. So sodium has atomic number of 11, therefore its electronic configuration will be 2, 8 and then 1. Magnesium will be 2, 8, 2. Aluminium will be 2, 8, 3. Silicon will be 2, 8, 4. Phosphorus will be 2, 8, 5. Then sulfur will be 2, 8, 6. Chlorine will be 2, 8, 7. And argon will be 2, 8, 8. Okay, so if you see here, this is the outermost shell of these elements. Okay, so the outermost shell is the M shell because it is always K, L, M. The first shell is K, then second is L and the last is M here. So if you see here, if you are moving from left to right in a period, the number of valence electrons are actually changing from 1 to 8. Okay, that's what I have written here. On moving from left to right in a period, the valence electron in element increases from 1 to 8. Now let us jump right into the second property. So the second property is valency. So let us see what will happen to the valency if you move from left to right in a period. So what is valency? Valency is the number of electron you will gain or lose or share in order to achieve noble gas configuration, or you can say in order to have 8 electrons in the outermost shell. So on moving from left to right in a short period, the valency of element first increases from 1 to 4 and then decreases to 0. So if you see here, this is 2, 8, 1, it is 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, then it is 2, 8, 6, 2, 8, 7 and 2, 8, 8. Now in order to achieve the noble gas configuration, sodium will have to lose its 1 electron and that is why it will be plus 1. Similarly, magnesium will lose 2 electrons and that is why its valency will be plus 2. Now aluminium will have to lose its 3 electron in order to have 8 electrons in the outermost shell and that is why its valency will be plus 3. Now silicon is going to share its 4 electron and that is why its valency is plus 4. Now phosphorus, since it is having 5 electrons in the outermost shell, so it won't lose its 5 electron, it is going to accept 3 electrons in order to become stable and have the electronic configuration as 2, 8, 8 and that is why its valency is minus 3 because it is accepting 3 electron. Similarly, sulfur is going to accept 2 electron and that is why its valency will be minus 2. Chlorine is going to accept 1 electron, and that is why its valency is -1. Now argon already have noble gas configuration, that is why it will neither accept the electron nor it will share the electron, and neither it will lose the electron, and that is why its valency is 0. So if you see here, the valency is first increased from 1 to 4 and then it is decreased from -3 to 0. So we have covered valency and valence electron. Now let us talk about atomic size. So the atomic size is actually represented by the atomic radius. On moving from left to right in a period, the size of atom decreases. Now this is very important, that why atomic size decreases as you move from left to right. So if you see here, sodium is having atomic number of 11. It means it has 11 electrons and 11 protons, right? Similarly, if I talk about magnesium, it is having 12 electrons and 12 protons. So as you are moving from left to right, the number of electrons and protons are increasing, right? So if I consider till halogen group, which is still chlorine, so what will happen is, as you move from left to right, the positive charge in the nucleus increases and the electrons are pulled in closer. So what do we mean by that? As you will increase the number of protons, the number of electrons will also increase, because of which there will be a strong force of attraction between electrons and protons, and therefore electrons will be attracted towards the protons which is inside the nucleus, and the size is going to shrink. And therefore as you will move from left to right, the size of atom is going to shrink because of large force of attraction between electrons and protons. I hope this is clear now. Now here is a small exception. Although the noble gas argon is placed at the rightmost side, but it is not having the smallest size. In fact, the size of argon is greater than the size of chlorine. This is because since argon is having 8 electrons in the outermost shell, that is why it has structural stability, because it has 8 electrons in the outermost shell, and therefore the size of argon is greater than the size of chlorine. In fact, the elements of halogens have the smallest size in a period. Now let us talk about the next property. So next property is metallic character. So what will happen if you move from left to right in a period? The metallic character decreases. Let me tell you why. So if we talk about sodium, its electronic configuration is 281. So it is going to lose its 1 electron in order to become stable. Now magnesium is 282. Again it is going to lose 2 electrons in order to become stable. Then aluminium is 283. Now sodium will be highly metallic than magnesium and aluminium. This is because it has to lose only 1 electron, and that is why if I talk about the metallic character, it is going to decrease from left to right. Okay, if I talk about silicon, so it is 2,8, 4. So it is actually a metalloid which shows the property of both metals and non-metals. Now phosphorus, sulfur, chlorine and argon. Now phosphorus, sulfur and chlorine, they belongs to non-metal. Now phosphorus is 2,8, 5. So it has to accept 3 electrons to become stable. And sulfur is 2,8, 6. It has to accept 2 electrons to become stable. And chlorine is 2,8, 7. It has to accept 1 electron to become stable. The non-metallic character is going to increase. So if you see here, we are moving from a metal to a non-metal. That is why metallic character decreases from left to right. Moreover, chlorine has greatest non-metallic character. This is because it has to accept only 1 electron in order to become stable. So non-metallic character increases from left to right, whereas metallic character decreases from left to right. Talking about argon, so it is actually a noble gas. Now on moving left to right in a period, the chemical reactivity first decreases and then increases. So what do we mean by that? If we talk about sodium, so sodium has electronic configuration 281. So it can lose one electron very easily in order to become stable, and that is why it is highly reactive metal. However, if I talk about magnesium, so in order to become stable, it will have to lose 2 electrons. Now losing 2 electrons is much more difficult than losing 1 electron, and that is why as you move from left to right, the chemical reactivity decreases. Talking about aluminium, so it has to lose 3 electrons. Again, losing 3 electrons is a very difficult task, and that is why aluminium is less reactive than sodium or magnesium. Now silicon. Silicon has 4 electrons in the outermost shell, so it is actually sharing the electron. Now silicon is so less reactive that it does not even react with water. Now phosphorus, sulfur, chlorine, they are actually non-metal and they gain electron in order to become stable. Now here phosphorus has to take 3 electrons in order to become stable, and taking 3 electrons is actually a big task. That is why it is less reactive than that of sulfur or chlorine, because sulfur has to take only 2 electrons in order to become stable and chlorine has to accept only 1 electron in order to become stable, and that is why chlorine is highly reactive, right? So therefore we can say that the chemical reactivity first decreases and then it increases till chlorine. Talking about argon, so since it is a noble gas, that is why it is inert and is chemically very unreactive. That is why we do not consider noble gases while explaining the trends in periods. Now let us move into the next property. Now the last which we are going to discuss is nature of oxides. So we are going to see what will happen if we are going from left to right in a periodic table. So if we talk about sodium, so sodium is actually a metal and every metal forms basic oxide, right? And every non-metal forms acidic oxide. Now in a period we are moving from metal to non-metal. So sodium is going to form basic oxide whereas chlorine is going to form acidic oxide. So we can say as we move from left to right, the basic nature of oxide decreases and the acidic nature of oxide increases. Here also we are not taking into consideration the noble gas. So this was all about the characteristics of period in a periodic table. Now let us quickly jump on the characteristics of groups. Now in a group what we are going to do is we are going to move up and down. So we are going to see what will happen if we are going down the group in a periodic table. So the very first property here is valence electron. Now let us see what will happen to valence electron. So when you move down the group, the valence electron remains same. That is, the number of electrons in the outermost shell remains same. If you see here, beryllium is having the atomic number of 4. That is why its electronic configuration will be 2, 2. Whereas for magnesium it will be 2, 8, 2. And for calcium it will be 2, 8, 8, 2. So here if you see we have 2 electrons in the outermost shell. That is why we can say that on moving down in a particular group of a periodic table, the number of valence electron remains the same. Now let us talk about another property which is valency. So valency is the number of electrons you are gaining, sharing or losing in order to become stable. So if we talk about lithium, its electronic configuration is 2, 1. So it is going to lose 1 electron in order to become stable. Similarly, sodium, it is 2, 8, 1. Again, it is going to lose 1 electron in order to become stable. So it is plus 1 valency here and plus 1 valency here. Potassium is 2, 8, 8, 1. Again, it is going to lose 1 electron in order to become stable. So here if you see, the valency remains same as you move down in a group. So all the elements in a group have the same valency, and that is the reason they are kept in a single group. Now let us talk about another property which is atomic size. So atomic size is represented by the atomic radius. So let us first write K, L, M, N, right? So these are number of shells. So hydrogen will be having 1 electron in the K shell. lithium will be having 2, 1. So it will be having how many shells? 2 shells. So hydrogen is having 1 shell, whereas lithium is having 2 shells. Talking about sodium, its electronic configuration is 2, 8, 1, and that is why it will be having how many shells? 3 shells. Whereas potassium, it is 2, 8, 8, 1. So it will be having how many shells? 4 shells. So if you see here, as we are moving down in a group, the new shells are added at every step, and that is why we can say on moving down in a group, the atomic size increases. Now here is a very small concept in which we are going to understand how to calculate group number and period number of a given element. So if we talk about the period number, so period number of an element is equal to the number of electronic shells in its atom. For example, if we have to calculate that potassium belongs to which period number, so what we are going to do is, we are going to do its electronic configuration. It will be 2, 8, 8, 1. So it has KLMN shells. So in total it has 4 shells, right? So its periodic number will be 4, that is, it will belong to 4th period. Also, we have another topic that if 2 or more elements have the same valence shell, then they belong to the same period of the periodic table. For example, if I talk about sodium and magnesium, so the electronic configuration of sodium is 2, 8, 1, whereas magnesium is 2, 8, 2. So since sodium also have 3 shell, whereas magnesium also have 3 shell, thus we can say that sodium and magnesium belongs to the same period of the periodic table. If you check here, sodium and magnesium, it belongs to 3rd period, right? And potassium, which has the atomic number 19, is having 4 shells, and that is why it belongs to the 4th period. Now, in order to calculate that which element belongs to which group number, we need to follow these rules. So, for the group number of an element having up to 2 valence electrons, the group number will be equivalent to the number of valence electrons. For example, if I talk about lithium, so lithium is 2, 1. So its valence electron is 1, which is less than 2. So it means it will belong to group number 1. Similarly, if I talk about magnesium, so magnesium is 2, 8, 2. Now its valence electron is equal to 2. It means its group number will also be 2. Now the second point, the group number of an element having more than 2 valence electrons, then the group number will be equal to valence electron plus 10. For example, if we have to calculate the group number of carbon, so we know that carbon is having the atomic number of 6. So it will be 2, 4. Now the valence electron, which is 4, is greater than 2. So if you have to calculate its group number, it will be valence electron plus 10, which is 14. So carbon belongs to 14th group number. Similarly, if I talk about neon, so neon has the atomic number of 10, which is 2, 8. So its group number will be the valence electron, which is 8 plus 10. So it means neon will belong to 18th group number. Now here is an exception. Helium has 2 electrons in the outermost shell. Still it does not belong to group number 2 because it is actually a noble gas which belongs to period number 1 and group number 18. Now here is a very small question for you. Which of the following belongs to the same period and the same group? So you have 3 elements here and you have to tell that which of them belongs to same period and same group. So first of all, let us see its electronic configuration. So it will be 2, it will be 2, 8 and it will be 2, 3. So element B and element C, they have same number of shell, that is 2, and that is why they will belong to period number 2. Now let us see which of them belong to the same group. So if you see here, none of them have the same number of electrons in the valence shell. So it seems to us that none of them belongs to same group. But hey, if you see here, this is actually helium, because helium has the atomic number of 2, and that is why it belongs to group number 18. Similarly, talking about element 2, so it has 8 electrons in the valence shell, and that is why its group number will be 10 plus 8, which will be 18. And if we talk about element number C, so it has 3 electrons in the valence shell, which is greater than 2, and that is why its group number will be 10 plus 3, 13. So here if you see, element A and element B belongs to the same group, which is actually a noble gas group. I hope with this example, the concept of group number and period number is clear with you. Now, let us talk about another property, which is metallic character. So, every metal is actually electropositive. That is why we can say metallic character or electropositivity. So, as you move down in the group, the metallic character of element increases. Now, let me tell you why. This was because the distance between the nucleus and the outermost electron becomes very high, and that is why there is less amount of attraction between the nucleus and the electron, and therefore it is very easy to remove the electron from the outermost shell. For example, if I talk about lithium, so it has only 2 shells, whereas sodium has only 3 shells and potassium has 4 shells. So as you will move down in the group, the number of shells will increase and the force of attraction between the outermost electron and the nucleus will decrease, and therefore it will be very easy to remove this outermost electron. Now the next is non-metallic character or electronegativity. So whenever any element is accepting the electron, it will become electronegative, and we know that it is only non-metals which accept the electrons, and that is why they are electronegative elements. So on moving down the group, the non-metallic character of element decreases. This is because with the increase in size on moving down the group, the attraction of nucleus for the incoming electron decreases, and therefore it is not easy to form negative ions. So in order to become electronegative, these elements actually accepts the electron. Now after accepting the electron, if the nucleus is able to bond them strongly, only then the element will be electronegative. Now as you move down the group, the atomic radius increases, and that is why the nucleus is not able to hold the incoming electron tightly, and therefore atom is not able to form negative ions easily. So as you move down the group, the non-metallic character decreases. So you can say the fluorine is most electronegative among all the elements in this group. Now talking about the next characteristic, which is chemical reactivity. So if the metal is able to lose the electron very easily, then it will be highly reactive, whereas if non-metal is able to accept the electron very easily and become stable, then it would be highly reactive. So on moving down the group, the chemical reactivity of metal increases as the tendency to lose the electron increases. So as you move down the group, the distance between the nucleus and the outermost electron increases, and that is why it is very easy to remove the electron from the outermost shell, and therefore francium is having the highest chemical reactivity. Now talking about non-metals, so on moving down the group, the chemical reactivity of non-metal decreases as the attraction for incoming electron decreases. So what happens is, the electron which fluorine has accepted in order to become negative ion, fluorine is able to keep that electron with a strong force of attraction, whereas iodine, it is not able to keep that electron with strong force of attraction. That is why as you move down the group, the chemical reactivity decreases. So fluorine is highly reactive if we talk about the elements in this group. Now let us talk about the last property, which is nature of oxides. So
We know that all the metals form basic oxide, whereas all the non-metals form acidic oxide. So as you move down the group, you will get only basic oxides, and as you move down in a group of a non-metal, you will get acidic oxides only. So on moving down in a group, there is no change in the nature of oxides of elements.
So it was all about characteristics of periods and groups. I am going to meet you again in the next session, in which we are going to start with physics of class 10. So we are going to start the chapter electricity. Till then, take care and keep learning.